Alright, our calculators have been put away. We now want to find some limits analytically. That means we're going to do it by algebra. They start out really easy. Let's look at this example. The limit as x approaches -3 of 3x plus 2. The first thing you should always try is just plugging in your x value. And this one works. I can plug in -3 for x, and I'll get -9 plus 2 gives me -7. And it really is that easy, you're done. So let's look at another example. This is one with the composite function. See that on C, where we've got g of f of x. But let's go through them one at a time here. On A, it says the limit as x approaches 1 of f of x. So I'm looking at f of x, and I'm just going to plug in 1. 4 minus 1 squared. 4 minus 1 is 3. Done. Going on to part B, the limit as x approaches 3 of g of x. So I'm going to plug in 3, get the square root of 3 plus 1, which is the square root of 4, which is 2. And now here's the point of the problem, the composite function. The limit as x approaches 1 of g of f of x. Now I could go through the hassle of taking f of x and plugging it in to g of x and getting the actual composite function and then finding the limit, but we saw in the notes that there's a really convenient shortcut. What you can do is you can find, oh no, it's just a message from my mother talking about painting a cabinet, ignore that. Okay, what you can do is you can find the limit as x approaches 1 of your inside function, which, by the way, is what we already did in part A. And so that's equal to 3. And then all you have to do is evaluate g of 3. You take your answer and you plug it into your outside function. And so if I plug 3 into that, I'll get 3 plus 1, square root, is 2. Nice convenient shortcut for those types of problems. Alright, the dreaded trig functions. These problems are not bad if you know your unit circle. There's a video in the introduction folder that will review the unit circle for you. All I have to do here is I have to plug in pi. So I've got the cosine of 3 pi. And remember, I don't have a calculator, so I've got to know what I'm doing here. 2 pi is once around the unit circle, so this is the same thing as the cosine of pi, which I know is -1. Okay, go check out that unit circle review if that was hard for you. I want to talk for a second here about zeros. Oh, Mama Schiefer played Mean Words with Friends. I've got to figure out how to turn off notifications. Alright, if I take 0 divided by some number, I know that I'm going to get 0. That's fine. If I have some number and I divide it by 0, I know that that is undefined. But if I have 0 over 0, that's what we call indeterminate. And whenever you're evaluating limits, what I need you to think when you see 0 over 0 is, oh no. When you see 0 over 0, you think, oh no, I've got to do something, and that thing that you're going to do is some algebra before you start working the problem. Okay? So let's take a look at an example. The limit as x approaches 2 of 3x minus 6 over x minus 2. If I plug in 2, I tell you that's the first thing to try. If I plug in 2, it's not just that I get 0 on the denominator, I also get 0 on top. And that's when you think, oh no, and do some algebra. You have some options for the algebra that you can try. My favorite is always factoring. Always look for something that you can factor. And so what I see here is on top, I can factor out a 3, which would leave me with x minus 2 on the top, which would cancel my x minus 2 on the bottom. So I've got a new function here. I can now rewrite this problem to say the limit as x approaches 2 of 3. 3 is just a horizontal line. If I plug 2 into that, I'm still going to get 3, and that's my final answer. So always look for things that you can factor. It goes pretty well. But of course the problems get harder. Let's take a look at this one. The limit as x approaches 0 of the square root of x plus 1 minus 1 over x. If I plug in 0, it's always the first thing we gotta try. I end up with the square root of 1 is 1, minus 1 is 0, over 0. No, I need some algebra to do. Well, I can't factor anything, but what I see is that I can multiply by the conjugate. Here's what I'm going to do. I'm going to take the square root of x plus 1, minus 1, over x, and I'm going to multiply that by its conjugate, which is the square root of x plus 1 plus 1. If I multiply the top, I also have to multiply the bottom. Now what's the point of doing this? If you think about a difference of squares, let's say I had a squared minus b squared. You know that to factor that, that's going to be a plus b times a minus b. That's your difference of squares. Look at the format that I've got going right here. I have a minus b and a plus b. Which means when I multiply those together, I can go backwards. I can go to a squared minus b squared. And stay with me, I promise it's going to help. So when I multiply those out, when I do the square root of x plus 1 times the square root of x plus 1, that just gives me x plus 1. And then 1 squared is going to be 1 over, and I'm not going to bother to distribute the bottom, you'll see why. Okay. So make sure you see that. I took this term and squared it and got x plus 1. I took this term and squared it and got 1. That gives me my form of a squared minus b squared. So I've got a squared minus b squared. And now my 1's cancel out. And I'm left with x over x times the square root of x plus 1 plus 1. And look what happens. The x cancels the x on the bottom, and I am left with 1 over the square root of x plus 1 plus 1. So I can rewrite my limit problem. I'm looking for the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now this is something that I can plug 0 into and get an answer. So I've got 1 over 1 plus 1, or 1/2, and we're done. Last problem, I've got the limit as x approaches 0 of the sine of 2x over x. First I tried just plugging it in. If I get the sine of 0 over 0, the sine at 0 is 0. Oh no, I need some algebra to do. I don't see any algebra right away that I can do, but what I know, because I studied my notes, is that the limit as x approaches 0 of the sine of x over x is 1. And I see that I've got a similar form to that, so I really want to be able to use this somehow. In the notes we called it u substitution, but here's another way to think about it. That's pretty nice. Something that we left out here. Yes, it's the sine of x over x, but really that's the sine of ax over ax, where a is any constant. The point is that as long as this term matches this term, then I can apply this limit. And so here, with the sine of 2x over x, if there was a 2 here, then I could apply that limit. I can put a 2 there if I'll balance it out. If I put a 2 on the bottom, I've got to put a 2 on the top. And the other thing I know is that I can pull constants to the front of a limit. So what I can say, I can rewrite this problem to say 2 times the limit as x goes to 0 of the sine of 2x over 2x. And because this matches this, I can apply this limit, and I can say that that's 2 times, and this whole limit is 1. 2 times 1 gives me 2, and we are done. And I will figure out how to turn notifications off so you don't read the banners of messages from my mother in the next video.